So one of the biggest skills in factoring is factoring trinomials. And these start kind of simple and easier, and then they get more complicated, as you can see here. And I'll try to show you both of them. But this is a skill that if you could go into Algebra 2 and be able to dust it off really quickly, it would be major advantage to you. Okay, so a trinomial, first of all. Tri means 3. Remember, a binomial was 2 terms. A trinomial is 1, 2, 3 terms. Okay, separated by a plus, minus, or equals. So we're factoring this trinomial. Now there's a difference between some of the simple ones and some of the harder ones, or more complicated ones. And that usually is whether there's a coefficient out here that's not just 1. Because right now that basically says 1x squared. We don't need to write the 1. Those tend to be simpler and can be done more quickly than ones like this, where the coefficient is not 1. It's a bigger number. Okay? So let's go back and look at this one. If I wanted to factor a trinomial, it's going to be 2 sets of parentheses. And what we want to do, if this is a 1, is try to find numbers that multiply to 18 that add or subtract to 9. And Dr. Conklin showed us this on our last video. You can make a little, sort of like a little crisscross X, just to organize your numbers a little bit. What are factors of 18 that add or subtract to 9? So just help us organize our ideas here. The factors of 18 are 18 times 1, 9 times 2, 6 times 3. I don't think there's any more, right? So which set of these adds or subtracts to 9? And I see it's probably the 6 and the 3, because there's no other way to get to 9 by adding and subtracting 18 and 1 or 9 and 2, but 6 and 3 is 9. So that means we're going to have a 6 and a 3. Both of them will start off with an X. Now, we need to get to a positive 9. The only way to get to a positive 9 is go up 6 and up 3. Now, if you wanted to remultiply that, you'd see that you would end up right back where we started. So that is factored correctly. Try another one. 2 sets of parentheses. And they're both going to start off with, I didn't start this one the same way as the last one, but let's put y and y in there, because y times y is y squared. Now, factors of negative 10, right, that add or subtract to negative 3. So what are factors of negative 10? Let's see. Negative 10 would be, 5 and 2. You could do 5 times negative 2, negative 5 times positive 2, 10 and 1. So you go 10 times negative 1, negative 10 times positive 1. I think that's it, right? But which set gets us to a negative 3? Well, 5 and 2 subtract to 3, right? So we know it's not going to be the 10 and the 1. So 5 and 2 get us to 3. But we need to get to negative 3. So it looks like it's going to be negative 5 and positive 2. Because that's the only way I can go from down 5 up 2 and getting me to negative 3. That's it. One more like that. 2 sets of parentheses. M times m is m squared. Factors of 32 that add or subtract to negative 12. Let's see. 32. Let's see. 32 times 1. 16 times 2. 8 times 4. And I think that's all I can think of, right? 32. But which set gets us to a negative 12? Now, important thing to think about here is to get to positive 32, these could be positive 32 times positive 1, positive 16 times positive 2, positive 8 times positive 4, but it could also be negative 32 times negative 1, negative 16 times negative 2, negative 8 times negative 4. Now that makes more sense. This is going to get us positive 32 when we multiply, but negative 12 when we subtract. And that is done. Okay, now we're going to write down coefficients greater than 1. This is where it gets a little bit more complicated. But I have a method that works every single time. It's not super short, but if you know how to do it, you really will never get tripped up. So, first thing, as we know, we talked about in the last week or so, is you always look for a greatest common factor first. And there isn't one. There's no number that goes into 12, 5, and 3, other than 1, but we don't count that. So, once we know that there is not a greatest common factor, and we have this giant number out here that in the easier problems didn't exist, what you can do is multiply the first number by the third number, which is 36. So I'm going to put 36 out here. Now, what are factors of 36 that add or subtract to 5? Right, we have 12 times 3, we have 18 times 2, we have 9 times 4. I think I just found it, right? 9 and 4. They multiply to 36, and they add or subtract to that 5 in the middle. So this is what I call splitting the middle. I take the middle term, and I split it. Instead of having it positive 5x, I have 9x and 4x. I'm going to break it up into two parts. Instead of having it one giant 5x, it's now 9 and 4. But how do I get to a 5? I'd have to go up 9 and down 4. So 9x minus 4x is the same thing as 5x. It's just a different way to write it. Then I bring down the first and last term again. So I basically now have no longer a trinomial. I have a polynomial of 4 terms. They don't call them quadnomials or fournomials. They're just called 4-term polynomials. So then what I do is I group the first two and the second two. And then I go back to my GCF knowledge. I say to myself, what could I take out of this one? Let's see, a 12x squared and a 9x. I could take out a 3x out of both of those terms. If I divide them both by 3x, I have 4x plus 3. Then I go over to this one, and it doesn't look like I can take out much of anything, but you have to take out something. So you can, if the biggest thing you can take out is a 1 or a negative 1, then do it. And in this case, it starts with a negative, so I'm going to take out a negative 1. And when I divide both of these by negative 1, I get 4x plus 3. Now magic happens here every single time. This one and this one will always match. That's the exciting part, and you know you did it right. So then what I do is I basically take these out and write it one time. I'm actually factoring out that 4x plus 3. And that leaves me with the leftovers, 3x minus 1. And then you're done. Now the first couple times you do these, you're like, this is crazy. It's too many steps, it's complicated, but then as soon as you get to like the third or fourth or fifth one, you're going to love this method, and it's going to work, and it's going to save you in Algebra 2 big time. So let's try one more. Ready? You always look for a greatest common factor. And 8, 10, and 3 do not have one. Okay, so now we know we're going to have to do it the new way. 8 times 3 is 24. What are factors of 24 that add or subtract to 10? Let's see, 24 and 1, 8 times 3, 6 times 4, 12 times 2, 12 and 2 do it, right? 12 and 2 multiply to 24 and add or subtract to 10. So now I'm going to split the middle. I'm going to split that middle term, and instead of 10x, I'm going to go up 12x, down 2x. That's the way I get to 10x in the middle. Then I drop down my first term and my third term, fourth term. The next step was to group them into two chunks like that, and then take the greatest common factor out of each one. So it looks like I can take a 4x out of this one. And that leaves me with, if I divide this by 4x and this by 4x, it leaves me with 2x plus 3. And here's that same situation again. Look, I have to take something out, so I'm going to take out a -1 again. And when I divide by -1, that's going to leave me positive 2x, positive 3. And magically, this happened again. So I take this one, and I write it one time, 2x plus 3, and here's my leftovers, 4x minus 1, and you're done. So let's see if you can try these two. A simple one here, where you just put the x and x and finish it from there, because there's no coefficient other than 1 there. And then another one where there is a coefficient. So 3 times 2 is going to be 6, and you're trying to find factors of 6 that get us to -5. And I'll give you a hint. It's this one, when you split the middle. All right. Take it from there, and we'll be live tomorrow.